let's have a panel debate here. We're going to be starting out with some questions and some discussions just within the panel, and then we will be opening it up for audience. I have Vanis Babodi here from Starburst, which is the first aerospace accelerator, I believe, in the world. He is here to moderate the panel with me. And the topic of the panel, and I'll let Van take it from here, but it's very simple. What's been happening, what is happening, and where are we going?
Thank you, Trond. Thank you. Okay, this is a fantastic mix of panelists, because really what you have is some great experience from different elements of the value chain. Anything from sort of early stage proof of concept development at the academic level. With Jaime, I'd like him to kind of touch a little bit on what we're seeing now, I mean, which he presented already, but kind of how we see that transitioning into some of John's experience with Aurora and how he's seen his business grow over the last decade, to eventually working with the companies like Lockheed, where Adam is right now, and actually, funny enough, where Aurora originates from, and then with Safran, we'll hear a little bit more from Gregoire on how now you're taking that sort of corporate strategy and siphoning that into investment arm that's actually now commercializing and thinking more intuitively about what it means to invest and partner with other talent that's out there and for your own future, the future of your business. So with that, I'll ask each of the panelists to, I think everyone knows, but quickly introduce yourselves and what you get really excited about. And I'll start with Jaime first.
Okay. Well, I'm Jaime Pereira. I'm the head of Aeroastro here at MIT. I already said, I think we are seeing lots of changes in the field. We didn't used to think of aerospace when the word innovation came out. It used to be, the general concept was it was a much more static industry where things happen in glacial times and or geological times. Everything was very slow, very large capitals, very long investments. That's really changing completely. Just as a data point, let me say, we graduate about 60, 70 students every year. And the large companies always tell us that they would like to hire more of our students, but the reality is that even a small number of students who graduate, more than 50% choose to go into areas that are not traditionally considered the large aerospace companies. They really want to start up companies on autonomy or you name it, or big data, whatever it is. So we are a source of technology. A lot of technologies do really get initiated in aerospace, but now we are getting to the point where the products are becoming affordable enough that it is a very fertile ground for development.
What do you tell students now who, in our generation, previous generation, kind of came out of schools thinking, I want a job for life, and are now thinking, do I want to work for an emerging company like SpaceX, or do my own thing? What's your advice to them?
Well, the advice is do what you're passionate about, but the truth is that this is happening more and more. Students do really want to go to companies where things happen, either smaller companies. I mean, I was talking to John earlier on, and Aurora, for example, is a company that hires a lot of MIT graduates, but Aurora has a size where the students can go in and still see the life of a project. They can get a general sense of what's going on. Sometimes when you go to the larger companies, they get so pigeonholed into an area that it's really becoming very uninteresting. So that's something that I think the larger corporations have a real challenge in really attracting the talent and offering attractive job opportunities for talented people.
Sort of question. We're very proud of our gender diverse panel here today. Can you make a comment on that?
Actually,
that's a very good point. Let me tell you, it's a very male-dominated domain. This is one of the top priorities in the department. When we I'm very proud to say that whenever we compare MIT to any other aerospace department in the country, we do pretty well in terms of diversity, much lower than we would like to, but our undergraduate population has about 30% women, and that's not as good as we would like to. But I should also say that this is a little bit misleading, because aerospace is kind of rather diverse, and even within aerospace there are some areas where we have much more diversity than in others. Big problem. We are missing on a big opportunity, and I think that's something we really should all be working on.
There is some organizations. Jeanette from my team actually organizes receptions for female engineers in space. What was your name again? Sorry. You also organize a sort of a collection of female engineers in school out of the program. I know that there's the Women in Aerospace conference happening in DC tomorrow. So there's.
We had the Women in Aerospace symposium that we jointly organized with Stanford starting this past year, and
So I pledge next year we will do better.
Trying to attract, trying to showcase what we do in aerospace, and really we need to start hiring faculty. We need to attract more students. I think it's really, we need to bring in more diversity at all levels.
Okay, but you did mention John and Aurora. I'd like to maybe quickly introduce yourself and talk about your experience and how you've seen your business progress, and again that value chain of how you source talent today and how you make yourself an attractive environment.
Sure. My name is John Langford. I'm a graduate of the MIT Aero Department, and I'm the founder and CEO of Aurora Flight Sciences Corporation, which we started out of the department back in 1989, at the time when unmanned aircraft was really a fringe technology, and you had to tell people what a UAV or a drone was when you met them. Today, of course, it's in the news every day and in every type of media. But we went through that startup phase at a time when it was not popular, there was no support infrastructure like there is today. I think it's fantastic to see the sort of entrepreneurial community that has grown up around MIT, and we have some specific suggestions on how MIT can help push that and continue to grow it.
So you just touched on a really interesting point, is the times have changed, and is it that much more of an enterprising entrepreneurial time for this industry? I know that's something that I'm very passionate about and we see a lot of today. Adam, maybe you did your presentation just now, and how you continue to monitor what new technologies are out there, but tell us a little bit more about how you and your personal interests and how the company really endorses your ability to go out and continue to source that talent and think about entrepreneurs out there as a partner for Lockheed.
Yeah, absolutely. Apologies that you have to hear from me twice. I made sure Tron knew I'd double bill him for it. But talent acquisition is probably a number 2 or number 3 strategic priority for a prime like Lockheed Martin. I mean, I want to make that clear. We know this is an issue. At the same time, I think it's incredibly important the way that innovation and the growth in startups and private venture capital have created an outlet and a way to attract non-traditional students and entrepreneurs to this industry. I came from the energy technology sector beforehand. You saw it with clean tech, and it created some level of irrational exuberance, but at the same time, when you tell smart people that they can actually solve a problem, it's amazing what happens. And I think Lockheed needs to figure out a way, just as all of the other large primes, to interface with that energy. And my push, as someone who's more involved with strategic partnerships and investments, is that it's really that open innovation idea of it's not that you have to hire somebody or acquire someone for their innovation to help you as a big company. There's lots and lots of ways, lots of tools in the toolkit. And it makes it, I think, even more important when you think about what Jaime said, for example, which is that young people may or may not want to work in a large prime. And that's okay. I certainly understand that. But we want to figure out a way to at least be able to not only add value to them, but create a long-term partnership that's mutually beneficial.
It's interesting what's going on today in aerospace, particularly in the drones and the commercial space, is a chapter right out of Clay Christensen's book. I mean, The Innovator's Dilemma. And it explains perfectly why companies like Lockheed are challenged to do innovations in disruptive technologies, and why the sort of life cycle of small businesses, that creative entrepreneurs come out of places like MIT, they start businesses, they grow up, they get acquired by the larger, more mature companies. It's not that Boeing can't develop an airplane like the ScanEagle. That came out of a small company. Boeing acquired that technology once it had driven the risk down. A lot of it has to do with risk and return investment, and the fact that the big companies have largely, you know, the industrial R&D labs, Bell Labs, Lockheed used to have the Kelly Johnson, Rye Canyon, the big research facility. Those are mostly gone now, and what's replaced it is this cycle of small companies innovating, growing up, big companies acquiring the technology as a risk reduction measure. And you can be a part, the message to the students is, you can be a part of that. This is a pretty understandable machine that, you know, for which venture capital is the lubricant, but you can be a part of that life cycle. This is not an anomaly, right? This is the way it's done in today's economy.
But the truth is that acquisition heritage is changing. I think some people recognize, just right here, BBN's acquisition into Raytheon, did that stifle its future growth looking forward? So how does established industry now think about alternative ways? Adam mentioned strategic partnerships, open innovation. Gregoire, a little quick intro about yourself and how you are basically shaping the strategy of your corporation to embrace open innovation and help educate industry stakeholders that there are alternative ways of just traditional corporate venturing that eventually wants to get to a point of acquisition that might eventually stifle that innovation in that group.
Very good questions. First, thank you very much for welcoming me here today. I'm very honored to be here. Maybe a few words about Safran because it's maybe less known here in the area. I'm very pleased, by the way, to have a blue badge because I've heard that I should have had a yellow one because Safran is not exactly a startup company, even if the venture group is a startup itself. Yeah. So quite funny. The group has mixed roots. Very old story. It started 100 years ago with Roland Ghosn, the first engine manufacturer in Europe, with the first pioneers, Blériot, you know, the people who crossed the channels in Europe. It has completely changed over the last 100 years. Last change was 10 years ago when it merged with an electronic and defense activity called SAGEM to set up Safran. And a few years ago, 3 years ago, the previous CEO thought that there were many bright engineers within the group. You may have in mind that we are responsible for the propulsion system of the European space launcher from Arianespace, who is 70 successful launch during the last 4 years. We are also responsible for, with General Electric, our friends, of the CFM LEAP engine, you know, this big turbojet engine who is powering the Boeing 737 and Airbus 320. So lots of bright engineers, 70,000 people. But the previous CEO considered that there were also bright people outside the group. And it's sometimes something interesting to have this kind of vision. We want to attract inside the right people, but we also want to deal and interface and team partner with bright people outside the group. So that was basically the roots of the foundation of this corporate venture activity, being able to make team and buy, make partner and buy.
Don't know, but Starburst's genesis was actually in Europe, where we basically try to coalesce all of industry, corporates, open innovation activities into a single gatekeeping forum. In Europe, the supply chain is much more hierarchical, so it's easier for you to have that co-opetition or partnerships with greater industry to make that sort of environment a little bit more conducive to sourcing talent, investing in talent, and now kind of having established that, coming now stateside and continuing to kind of build on that. So where is Safran going next? What new technologies do you really get excited about?
Well, first, we indeed have different tools to interface with innovative people, startup companies. As many large corporations, we have those GDPs, joint development programs, set up with either SMEs or startup companies, and we would like to embed those, as I said, innovative people in our own programs. We are definitely very interested by everything around critical embedded, critical electronics, considering that safety, security, cybersecurity, stuff are completely new trends for us, and at the end of the day, we'll rely on critical electronics. So we have built a large GDP with other large European corporations and also SMEs and startups. So that's a way to interface with those startups. We also put in place different innovative purchaser within the purchasing departments to completely change or to move on our own supply chain. You may have in mind that the civil aerospace commercial aircraft business is facing a huge production increase of aircraft with the LEAP engine, the new engine. We've got to move from below 100 or 200 engine per year to 2,000 by the next 4 years. And it creates tension along all the value chain, all the supply chain. We will do it in 4 years, what we did in 20 or 25 years for the previous generation, meaning that we will rely on reliable suppliers, but we also want to, for new technologies and future generation, add innovative suppliers. And we have this last tools, the corporate venture.
So what have you invested in? So how many investments have you made this year?
Three investments.
In what?
We invested in, as I said, critical electronic and
Is the name of the startup public, or?
Yeah, Chronosafe. It's an operating system supplier for our types of embedded electronics. You know, the FADEC or the control circuits for the landing systems, or where you, as users, we want to have very reliable electronics. We investigated and invested on digital fab and augmented reality. We made one investment in this field. Okay.
Can I ask an outsider question here? So, you know, it's very easy to get very fascinated by aerospace, and I was as a kid. But, you know, and now apparently everything is changing. But, you know, as a sort of impatient outsider, and, you know, talking to my son, like, when are we going to all be traveling to Mars? Just a quick, just give me a sense. This is a good round here. When are we going to all have a drone? When will we have the option to actually go to Mars? Just answer my two quick questions.
So the drones, you should have one today, right? And 2030s for humankind to get to Mars. I don't know if that's not in the everybody category, but everybody should have a drone already. If you don't, you should go get one, because no excuse.
Thanks. Adam?
Yeah, I have a bumper sticker on my door that says 2030, so that's the Lockheed Party line, but I do believe in it. And then from a drone perspective, I mean, what I always say that I think is interesting is you look at really what we're seeing is proliferation of sensors, right? At the end of the day, whether it's remote sensing satellites or drones, there is no coincidence that the industrial Internet of Things and the growth in drones and the growth in small satellites for remote sensing have all happened within the same decade. Because what we need is data ingestion, and you could have that today.
Yeah. On the drones, I would just echo what has been said by John. But on the Mars issue, I think, again, yeah, when things get more than 10 years away, they all get very diffuse. But I think one of the challenges that people ought to realize is that we are becoming very risk averse. And when we went to the moon, there was a completely different situation, and we were willing to risk a lot more because we were perceiving an outside threat and things needed to be done. Nowadays, for Mars, I don't know whether we are going to have as a society, or how soon we will have the stomach it takes to take the risks it requires. Technology is one pacing item, but there is a big social issue surrounding it. But I would say, I would like to think that within 10 years, we may start seeing things, but clearly being able to master going to Mars will take a lot longer, I would say.
And I will not comment on Mars travel, but maybe more on drones. What's happening on drones for companies involved on heavier platforms such as helicopter is obviously also very interesting, because it definitely changed the way the architecture, the multi-rotor, the distributed generation, the VTOL, all those technologies are moving from small aircraft to maybe a larger aircraft, or at least it forces us to work on those technologies. So definitely within the next decade, we will see, and we start to see, there have been startups presenting today, new types of aircraft or cargo drones, flying machine. Yeah, definitely.
Well, there's more aircraft, there's more drones registered as under Part 107 today than there are aircraft already, as of less than a month of the registration being open. So,
yes, but at the same time, you know that the industry will have to deliver 37,000 new aircraft, civil aircraft, over the next 20 years, out of 20,000 short or middle range aircraft. So don't forget that the basic.
yeah. But I think I like to think of it more as when will we start to think of Uber regional transportation? So air taxis to do from regional airfields. So how soon will we actually be doing Minority Report style, call your Uber and then door-to-door pickup, and it'll take you to a regional airfield, get in a plane, fly somewhere, and then get to another air taxi and take you somewhere else.
5 years.
That's optimistic.
Yep. There's at least 5 serious major industrial companies working on that, and there's a lot of money going into it.
Yep.
I think, again, I bring the same topic. I think there is a consideration in aerospace that we tend to overlook, which is that aerospace, one of the particular things about aerospace is that aerospace is hard and products need to work because they are safety critical. Often it's not the technology what drives the adoption. There are lots of things that we can do once, we can do twice, we can do 10 times and make it work every time. But from here to gain the trust required to make this happen and to deal with all the legalistic issues, get airplanes certified, and that's a lot of.
I'd actually like to challenge that. I think it's kind of ironic in that what has conveniently been an establishment heavily regulated because of a safety critical regime, limited by or aware of technology, but it's actually the tech industry that's scaring or disrupting or creating a sort of a careful retreat, in the words of Clayton Christensen, in terms of the market opening up and new entrants coming in. So it's not just the Russians and the Chinese having an established familiarity of safety critical infrastructure.
No, it's a situation where one bad aeroplane, one accident can bring down a company.
But that's expected, and that's always been the case with the industry.
With aerospace, yes, but this is particular to the aerospace world. If you build applications for the iPhone, the level of scrutiny that is going to require to bring something to the market is going to be completely different. You can be in the world of 3D printing, and you can start putting out machines there and sell them that print plastic and sometimes works and sometimes do something different. Aerospace companies tend to be integrators. They need to put everything together and they need to sign on the dotted line. And I think this is real. But
these limitations are factors involved with carrying people. So I have a company in our program that's created a 777-sized amphibious drone to disrupt freight forwarding between air and maritime cargo. And they don't have to get the certification standards by the FAA because they're not carrying people. They're actually going to remote pilot or autonomously transport goods from a maritime rules perspective. So they don't have to go through as many hoops for certification or safety critical approval.
Let me just clarify that. I'm not disputing whether the hoops should be there or not. All I'm trying to say is that the hoops are there and this slows down development and adoption of systems. Deployment is affected by the regulation and by the standard. I think some of them are justified. Some of them may be overly restrictive, but I think this is a fact. I think regulation is...
And I would just pick up on what Jaime's saying a little bit, in that a lot of the new money and new interest is coming in from people who've been very successful in the fundamentally software-related domain. And there's some big differences with airplanes. You can't release a product that's 90% ready in the aerospace business. Even 99%, which would get you an A in any college course in the world, is not good enough for the kinds of stuff that we up here have to push out the door to fly. It's got to be many nines on there. The margin for mistakes, it's just a very unforgiving thing when you push stuff out the door and
So I know the guys at Scaled Composites pretty well, and they're not trying to fly 100% aircraft. They're actually pretty used to having crash landings and trying to be a little bit more experimental and getting aircraft up there.
Well,
So
and
that's
they've
the-
killed 7 people in
Yeah.
getting
but then they
the
got acquired by
Spaceship
Northrop,
Two
and
out
now
there,
they've got
so-
more stealth prototypes coming out of that facility than anywhere else. But Adam, you talk about
So
strategic
let's,
partnerships.
say, I
let's
mean, I
move
think
to
the-
another question here, which is let's get
to
out
have-
of
We
that
all agree it's
fixation.
hard. Yeah.
Let me move to a
Makes it more
fundamental
interesting.
question. So it's been said by far wiser people than me that space is the final frontier. Why are you personally engaged in space? In this domain. What got you into this, and why are we so fascinated? Why is my son so fascinated with this area? He's 7 years old. He should be playing, but he's talking about space and aircraft and I guess why are you personally engaged in this, and why are we all so fascinated?
Well, space is the next frontier. It's the frontier that we've all grown up with. I went to MIT because in the 60s, the Apollo program, I mean, that was the exciting, entrepreneurial, inspiring thing to do. I thought I'd be working on the Mars program in the 80s and 90s. Now I'm hoping that my kids will be able to work on a serious
always
Mars
10 years
program. But it's what's next. Mars is the next thing that we as a species have to do.
I mean, I think fundamentally what gets us excited at a place like Lockheed, and I assume is probably what drives a lot of you to the room, is that you look at something like a satellite, and it really is the culmination of some of the highest technology in almost every domain that we have, whether it's batteries, materials, power systems, optics. I mean, that's pretty cool that you can bring it all together. What I would say is, I think when we think about space as a frontier today, we need to take a more granular approach. At this point, low Earth orbit is another geography. I mean, it's a lot of ways what it was, to go to China 50 years ago if you were an American businessman. There are accessible ways to get there. You need to understand some of the regulatory concerns, but the risk is actually relatively low. Now, you want to start talking about even going to GEO or the moon, obviously. I mean, then there's complexity that's not the same. But the fact that, you could go out today as an ordinary citizen, you could get a CubeSat off the shelf, you could buy a launch through a rideshare provider, and you could have something on orbit in 2 years for a few $1 million. I mean, that's pretty cool.
Yeah.
Unless it blows up on the pad like last week. But,
No comment.
Yeah, and again, it went back to the debate we had around safety, and definitely safety is at the core DNA of our aerospace industry. But we also have to take into account that the modern world in which we are all living and the new types of threats we all live in, and it's not anymore only a question of safety, it's also a question of security, it's a question of cybersecurity. So in terms of barriers to entry, to development of all those new innovation, we've got to take into account those new threats and new...
So it's not a coincidence that it's 20 years since the Challenger accident. I mean, how much does a massive accident set back an industry like this? I mean, despite, because you're talking about fascinating things, you're talking about technologies. Behind me, your point was it's not just about the technology, it's about the societal and the willingness of the people who are going to be, flying these things or even just running these drones, and what kinds of capability are we willing to let those people have?
This speaks to the point I was mentioning about being risk averse. As sad as the Challenger accident was, which was, we really get people dying on a daily basis, and in terms of loss of human life compared to many other events, it was not such a big event, yet it was considered a major drawback, and it forced the program to be revised and all sorts of things. I mean, in another approach, in another type of society, one could have said, okay, well, one gone, let's just launch the next one. I mean, and this is the type of, it gets accidents, and there is the human perception and that aspect. How many accidents can we tolerate going to Mars? And if we have an accident, are we going to stop the Mars program, or going to keep on launching a spacecraft to Mars? I think this is an important reality. I would just very quickly wanted to address the question you said, why should we go into space? And there are many rational answers, and I have my own. I just love it. I think it's a great idea. But going back to the rational and to the policymakers, I think there is ample evidence that investments in aerospace are real generators and catalyzers of technology. And the reason for that is because we try to do things that have not been done before. We are trying to push the boundaries of performance. Maybe there are other problems where this happens too, but this is common. That happens in most products. You try to make aircraft that have longer endurance or a spacecraft that go further, and this pushes the envelope of what we can do in engineering, and this is why we generate so many technologies. So only on an economical basis, I think it makes sense.
I recall a comment that the Undersecretary of the Air Force for Acquisition made once, talking about the SpaceX development program. He said, look, you got to understand, if the Air Force had done, if that had been an Air Force program, they would have given up after the first failure.
Yeah.
If it had been a NASA program, they would have given up after the second failure. If it had been a DARPA program, they would have given up after the third failure. A lot of this is the willingness to kind of take risks, keep driving forward, and that's one of the important things that the sort of new tech side, I think, brings into it, that really is kind of shaking up the system.
Perhaps I could pose a question. I know I'm not supposed to be the one to pose questions, but how long do you think it's going to take until we see driverless cars without safety drivers? A technology which has been going on for a while. Apple has, or I mean, many people, Google. I mean, how long is it going to take until we see a car driving down Mass Ave without a driver on it?
Let's take an audience poll. Let's say next
see that
5
every
years.
day.
Next 5 years? Next 10 years? Next 15 years?
I probably am going
Anybody who does not believe that it's going to happen in the next 15 years, that
Well, I
there will be a
think-
driverless car? Okay.
But it's not.
What's your answer?
All I'm trying to say is not that
We don't
immediate.
know.
I think it's going to take a lot longer than people think. The technology's been out there. It works most of the time, but it doesn't work always, and this is a big problem. And this is what we are going to find. One day it's going to snow, the sensor is going to get clogged with the snow, and it's not going to work, and there's going to be an accident. I mean, can we afford that? I mean, that is the type of things that I was referring to.
And that's the difference between the automotive industry and the aerospace industry. We are the industry which is highly regulated and with a high level of certification, which is different with the automotive one. That's also why we consider that they could be transferred from aerospace to automotive. When I was talking about critical embedded electronics, that's definitely examples of technology coming from aerospace that could fit with the automotive business, considering we managed to reduce the cost.
Adam, in your earlier presentation, you talked about the decreasing amounts of government spending on research. A lot of the challenges I hear from startups today is they're not interested in government grants to continue to support their research. And John, I'd love to hear your views on that as well, because that's a big part of your business now. But that they're more interested in commercial indications, to say, I'd rather win a $200K commercial contract than I would a $3 million research grant. That way I can catalyze my business into the marketplace and become a contender to partner or do business with Safran and Lockheed. John, you have been through these hoops many times, and you have fantastic lessons learned, but really I want the two of you to maybe highlight a little bit more about where you see that going, and what lessons learned do you have for the audience today.
Yeah. I mean, speaking from a corporate venture perspective, I know that we counsel startups a lot to look at us as a resource to help them navigate and to help reduce some of the overhead that would otherwise be required to address some of these government funding sources. I mean, at the end of the day, it doesn't matter what industry you're in. If you have access to non-dilutive capital to help you go and de-risk something, I think it's very infrequent that that's a bad choice. So the question is, can you do it without having to build out an entire department that's managing contracting and FAR and all the rest? And we have an army of people that can help do that. So we often actually do partner in that way. The other thing is that to the extent that you do need an anchor customer like the government that has unique requirements, has a unique willingness to pay, one of the best ways to develop that relationship is to do early contract R&D with them. So I always counsel people to say, if your go-to-market strategy involves a commercial customer being your first paying customer, that's great. That does not mean that you cannot take advantage of government funding, and we would love to help you do that.
John?
Well, yeah, our business has gone over the years as a startup and then sort of growing out, being very heavily dependent on government contracts, to today we're about probably 60-40 in the government space. The Air Force is our biggest customer, and DARPA probably the second. But 60% in the government side and say 40% now in commercial. And they both have, it's like a balanced diet for a person, a balanced diet for an enterprise is a good thing. And there are pluses and minuses to both sides. I would say that the government, if you're thinking of starting a company, the U.S. government's Small Business Innovation Research Program is, I think, unparalleled in the world. I talk to people, colleagues in other countries, and they're absolutely amazed. The U.S. government will give you money to start a business. And I'm sorry, but you don't need Lockheed Martin to help you read the rules and write a proposal. I tell my engineers, if you learn how to write an SBIR proposal, you'll never need to go hungry again, because it's a competitive program. All the U.S. R&D agencies, the U.S. government are required to have it, and it's been around for 30 years. It's one of the best things the U.S. government does. It makes real impact for the country, and it's a great tool for people who are thinking of starting a business.
It is a double-edged sword, though. I think we need to be clear on that, because it's very easy to, I think, if at the end of the day what we're interested is in scalable businesses, self-sustaining scalable businesses, it's very easy to get addicted to a steady chain of SBIR funding in particular. So that's why I said I think it's important to have a business plan. That business plan needs to be a standalone business plan.
Right.
But using non-dilutive capital to help get you there, there's nothing wrong with that.
So John, is it safe to say then your business, having been successful at that, is now a commercial research entity versus a business that's actually really targeting that business investment case to really ramp up as a
I mean, I think where we are is in that transition to what we call a program of record, which is what in the aerospace business, that is what the Holy Grail is, whether it's a formal U.S. government program or it's a commercial program. Program of record is a long-term entity where you've moved out of the research stage and you actually are in the production, the operations maintenance cycle, and that's not easy, no matter how you do it. But that's how you become a Lockheed Martin, is you accumulate a portfolio of programs of record.
Exactly. Yeah. There's a lot of fantastic ideas in this audience. I heard some great presentations today. Some of you might be thinking, do you want to become a program of record entity? Do you want to grow into being one of those big entities? Or are you trying to capitalize on some of these LEO commercialization opportunities, the drone market, which is staggering enough to get the attention of venture capital? So they're capitalizing on the financial metrics. So maybe when's the right timing to open it up to the audience and start really challenging them to think about what are your business needs? Are you purely interested in capability? Are you trying to meet a use case? Or are you thinking about the business case behind your technology? And what's the right vehicle to pursue? And how can experts like this in every aspect of that value chain help you take that technology in a commercial sense?
I'm going to give the word to a woman first. So any woman who wants to speak deserves the right. Yes? Questions? You might think of one. Lots of men speaking. Let's start with you then.
In terms of space access and how that fuels new innovation in LEO, GEO, and even further on, how dependent do you think that is on the likes of SpaceX and Blue Origin, if they are slower than we all hope they will be in providing cheaper access to space? How much
do you think? Sorry, can you elaborate? You think SpaceX and Blue Origin are?
I mean, I'm hopeful that within, say, 5 years, it'll cost I don't know, $10 million to use a reusable SpaceX rocket. Let's just say that. If it doesn't turn out to be like that, how much do you think people are depending on that kind of progress for some of these kind of future ventures, like a Planetary Resources that wants to mine asteroids, or even other examples? Do you have any thoughts on that?
One of the other great MIT Aero Department startups, of course, is a company called Orbital Sciences, which Dave Thompson was a senior when I was a freshman, and he was sort of one of the inspirations that I think John Tilko and I both had when we looked at starting Aurora to sort of do on the airplane side what Orbital had done on the space side. Their goal was to provide launch access for under 10 million a launch. That was in 1982 when they started that company. So the old adage that the easiest way to make a small fortune in aerospace is to start with a large one is really being proven true, particularly by the two examples that you cited there. Those are things where there's a lot of money that's been generated in other enterprises and is now being applied to space launch, sort of like you were talking earlier. If you had $100 billion, you might start a rocket company too. You know, it's never too late to get into the aerospace business, even if you didn't leave high school and go to MIT Aero Department. Although I still think that's the best way, but it's never too late to get in if you've got enough money, and I think that's really the key.
Mr.
To what
Bronson
you're talking
and
about.
also Elon send their regards. They couldn't be here.
Yeah.
So one thing I would say is, I mean, low cost, reliable, available launch is clearly one of the biggest challenges to space innovation. I mean, full stop. But if you look at the fact I mentioned earlier that, you know, the launch of small satellites between, I think, 2011 and 2015 increased about 10x. It went from about 20 a year to almost 200 in 2015. None of those went up on a truly small launch vehicle, right? Because there really is no viable small launch vehicle today. And so people are finding alternatives. Rideshare is becoming an incredibly important part of the industry. You've got companies that are doing that as their bread and butter. Even ULA, almost every Atlas V that goes up in the future is going to have some level of rideshare on it. And so I think there's, you know, ways to work around it because it is clearly a known problem. And, you know, launch is incredibly hard. There's a reason, if you go back and look at the history of why the United Launch Alliance formed, it's absolutely fascinating from a business and a governmental perspective. And the challenge is that a lot of those dynamics are still here today.
Fundamentally, it was formed because people didn't think the market was big enough to have two rocket companies competing against each other, and we had to merge them.
Actually, it was a
you know,
result of
today
corporate
we have
espionage.
you know, I don't know how you count it, but at least 5 competing for that market. So.
You have a question? Okay.
Okay, so my question is, what are your guys' thoughts on the long timeline? Like, I speak with a lot of entrepreneurs that have like hardware, robotics, telematic-based startups, and they have trouble getting funding because of the long timeline. Because the investors obviously want to see much more than prototypes. They want to see like users or like actual traction. What are your thoughts on this long timeline, and how can entrepreneurs like not get deal fatigue or burnt out in terms of this and to keep on keeping on?
Can I say something first? I think you need to be very clear on what defines an entrepreneur. I think today's generation is often confused with being enterprising versus being an entrepreneur. And if you go to Silicon Valley today, people tend to define being an entrepreneur as being self-employed and being their own boss. When I'm a big believer that if a real entrepreneur is someone that's religiously passionate about solving a problem, and they've felt the burn and they've seen the problems and they're prepared to commit their life and sacrifice their time to really make something happen. So that's a really good question, and I think I'll let some of the panel experts kind of touch on that a little bit more.
Perhaps I could say briefly. I think the SBIRs are great, and there is a lot of options and opportunities for the short-term type research in that context. I think what is missing, and it's really missing, is the structure to support the big challenges. And for that I mean projects that may last 10, 15 years to see fruition, because we have governments that get elected every 4 years. And that's really missing. I mean, where is the strategy to invest in our next future transport aircraft? And that's very important. We have very timid efforts here and there, but it's so important to our economy that we should have, in my view, we should have a standing program just looking at that particular application. And that's something that should transcend the knowledge. This is why I think there is this article by Buzz Aldrin in Technology Review that he says, when we went to the moon, you guys promised the cure to many diseases. You promised me to go to Mars in 10 years. You promised me all these big problems being solved. And all I got is Facebook, Twitter, and some other things. And the truth is that a lot of this, the technology has evolved in a different way, but it responds precisely to that. It's fairly immediate challenges, the ones which we can address with the current structure.
So, Hemi, can I just try to understand what you actually mean by this? You're saying that even though we have an unprecedented level of innovation right now, it can become too much of a resting pillow for governments and people with really deep pockets, because venture capital, I mean, we have this issue in other sectors, certainly at MIT, right? Energy, other things. Infrastructure investments are traditionally not something that VCs want to touch because it
Exactly.
starts to hit the
Yeah.
100 million mark.
And I
which
think
is,
it's where the
out of reach
government
for
has a
VCs.
role to play, but I'm not sure it's playing it the way I would like to see it played. I think there should be, in the longer challenges, there has to be an underlying program, well-funded. If going to Mars is the challenge, we need to provision for that.
But
Or
you want
purely-
even entrepreneurs in this room to be eligible for these 100 billion budgets, not
Yes.
the 100,000 budgets.
I think the question really does touch on one of the things that makes aerospace different is it is the time scales.
Yeah.
It is the sheer amount of capital, right? The kinds of capital, the kinds of time frames that you need to take on these aerospace projects, even under the best of circumstances, are long compared to the typical VC cycle. And you know, that is one of the hard challenges about what we're all doing. There's, you know, the fact is most startups fail, right? And so it is a tough business. Those that succeed often end up reinventing themselves several times along the way before they sort of lock on to what makes them successful. That's what makes it challenging, and people do keep coming back despite that very hard.
We have time for about two questions. Just like 1, 2, 3. Anything here? We'll stay with you.
Right here?
Yeah. Did you want to say something?
No.
Please finish.
I was just willing to add one thing on your remark, the fact that even if this time schedule is the also DNA of our industry, we have to take into account that at the corporate level, either within the OEMs, airframers, other types of big corporation. What I was saying at the beginning, the fact that we were also considering that there were bright people outside our groups, the fact that all those new ecosystem with corporate venture, you have seen that many, the group decided to put in place this Safran Venture. Airbus did the same. GE exists for now 30 years. So definitely something is happening around this ecosystem, and how you shorten this time issue, and again that's true teaming up corporation and entrepreneurs. Entrepreneurs alone, maybe the question remains. Entrepreneurs with corporation, it's different.
You need to be a lot smarter about how you communicate your business to these guys. You don't let them pigeonhole you into being a hardware entity that lacks an investment case for an investor. You need to say you're actually doing software that creates automation that actually improves the efficiency of that supply chain for that production line. So you need to understand how your technology actually affects the value proposition for the client, which ultimately is coming sourced from the government, which feeds their economic engine.
Let's take another question.
So I have a question about the roles, as you see it, of academia and industry and innovation in aerospace. So in two senses. First, on the more individual level, and as like a curious student, what do you see as the value in getting a sense of innovation either through the academic world, through like PhD, or on the startup side, and looking at innovation in that sense maybe? And then in a larger sense, what do you see as the roles in aerospace innovation for academia versus industry and startups or big companies?
Well, I will start by saying times have changed. We were basically kicked out of MIT in the late 80s because we were getting too practical and too applied. I literally had professors say, "You guys want to build airplanes? That's not really what we do here at MIT. You need to go start a company." Now that turned out to be good advice, but I would say that the sea change is dramatic over the last 30 years, and so over to you.
Yeah, no, I would say that both are needed. I mean, when you refer to the startups versus the people that do deep research and develop new technologies and PhDs, but what is the role? I mean, our role is this is a people's business. I mean, this is why you mentioned that Lockheed is one of the top priorities to capture talent, and this is true. I mean, this is, you really want to get the smart people that are going to solve the problems, and you don't know what those problems are. So from our own perspective, education has its own challenges. Here is a domain that has been getting larger and larger and larger in terms of themes you like to cover. you still want to graduate in 4 years if you are an undergraduate, or perhaps in 4 years if you are a PhD. And we need to decide what we teach and what we don't. And that's proven to be a real challenge. And nowadays, I think the common accepted paradigm, I would say, is you no longer try to teach everything. People would really be able to find things on their own and learn on their own. What you really try to do is you try to demonstrate or educate through getting examples that integrate technology so that the students or people see how it's done once, so they can go and replicate it. But you just cannot cover every possible discipline on every single area. So, and that's been a paradigm shift for us. This is why getting these projects on campus, hands-on type capstone, what you were just referring, has become so crucial, because this is where everything gets together. This is where you have to make compromises. This is where you have to combine knowledge coming from many different sources. And that's something we really try to focus on these days. It's no longer anymore about knowing your dynamics or your fluid mechanics, which you still need to know to some level, but information is much more available than it used to.
And one thing I might add too is, where the dynamic is so challenging for startups in terms of these long development timelines, in a way that's almost a strength also, I think, for academic level research, because to the extent you're doing something that's maybe a little bit more basic science or immature materials development, for example, the fascinating thing about working at a corporate like Lockheed is, even if you're telling me that, you're not going to be ready for deployment in 7 years, I still care, because we have programs of record that aren't going to be delivered at least for another 7 or 10 years. And so there's not actually a lot of corporates in the world that have that long-term vision.
Right.
One of the big sort of friction points between industry and academia is the whole issue of IP ownership and licensing and stuff like that. It's been interesting for me to have a chance to compare MIT with a number of other universities. You have there's a real spectrum. Some of particularly the public universities, are seen very much as engines of local economic development. If you're Mississippi State or West Virginia University and you're getting state money partly because, or a lot because, they see you as an engine for driving the economy of that region. And they take a kind of a different approach to some of these issues with IP than some of than places like MIT. One of the roles that Aurora has been able to play, and one of the things that we've been really successful at, and it's the key to why our R&D center here in Cambridge has turned out to be such a good thing, is we've been able to kind of work both sides and become an interface between a lot of aspects of MIT and some of the other customers who would never put up with the intricacies, shall I say, of dealing with MIT and some of the ways they treat IP and things like that, that are issues that are real and important and barriers to working with MIT. But the people who can figure it out, that becomes a real advantage, a real competitive advantage.
So we're going to end on a real positive note, and people who know me know what's coming now. So we have like a radio second, which is 15 seconds for each of you. I would just want to hear, what is the single most exciting technology, company, idea in the field of aerospace innovation that you would like to share with the audience in the next 15 seconds? And then we're going to end on that note, on a positive note. This is what the top experts in the field thinks we should be thinking about, dreaming about, making in the next decade. John.
The D8 commercial transport. It's a joint effort between MIT, Pratt & Whitney, and Aurora. It's going to completely change the way all of us in this room fly in terms of fuel efficiency, noise, and emission standards. And it would never happen without a kind of partnership that we have with MIT.
Adam?
I think the proliferation of space data, it's really exciting, and whether it's coming from small satellites or large WorldView 4 type satellites, the availability and the ability for people to utilize that kind of data and find all kinds of really cool stuff. I mean, just think that you didn't have Google Maps in your pocket 7 years ago or 8 years ago, and how much that rules our life today. In 10 years, you may be able to just literally get real-time pictures of yourself from space.
Jaime?
After the D8 has already been mentioned, so I'm free to mention
That's
something
okay,
else.
you can say it too. You can say the same thing. It's
No,
okay.
to me, what really gets me excited, I think at heart I'm still perhaps a child, is really going to Mars. I really think this is going to be a tremendous feat for mankind. We will get there, and I'm just a fan of SpaceX. I think the whole vision on the whole idea of reusability and trying to make something like that happen would be just tremendous.
Greg.
Maybe not a specific technology, but a different approach, collaborative engineering. Maybe not crowd engineering as we already started to hear, and people claiming that now we will share our engineering resources through the crowd, because it raises so many issues in terms of licensing, IP, and an alignment of interest. But we definitely have to rely on the brightest brain we can find in the areas, either in our groups or outside our groups.
All right, and with that, I want to thank the moderator, Ivan, from Starburst. Thank the panel. Thank you, all startups. And just to say that I think there still is some more coffee. We're not going to kick you out. And you can see some of our work again at the MIT R&D conference in November. We are going to display a fantastic array of really deep science, deep technology startups. You can also see us in London on the 2nd of December. We are bringing digital innovation to London if they didn't have it before. And after that, we're just continuing month after month to tackle area after area, cancer, batteries, you name it. Thank you for your attention.